As a case study exercise for you, what I would like you to do is to have a look at the distribution of one particular species of animal that we find at hydrothermal vents and assess its vulnerability to future human activity and the importance of preserving it, of protecting it. So the species I'd like you to look at is the scaly-foot gastropod, Chrysomalon squamiferum. Okay, so this is a species that we find at hydrothermal vents in the Indian Ocean, so I'll give you that to start with. It's a species that lives with endosymbiotic bacteria in a bag attached to its esophagus. It's a very remarkable gastropod because it's called the scaly-foot gastropod because its fleshy foot is covered in plates of metal mineral, iron pyrite primarily. Okay, and that's actually a detoxification mechanism that the snail has for living at hydrothermal vents. So what I would like you to do is to do some research. Okay, you can do literature search. You can also look at various databases that are out there, such as OBIS, that have records of species in the deep ocean. And the first thing I'd like you to find out is how many vent fields does the scaly-foot gastropod live at that we know of so far? Okay, where has it been recorded? How many vent sites do we know have populations of the scaly-foot gastropod? So that's the first task. Then, once you've got those vent sites plotted, I'd like you to go and have a look at, you can visit the website of the United Nations International Seabed Authority and look at where are the areas where people are interested in future deep sea mining in relation to where the scaly-foot gastropod lives. So see if any of those areas where you found it are areas at risk from future deep sea mining. And then finally, I'd like you to do some further literature search to see what the scaly-foot gastropod has already taught us for materials science. So its shell has a very different structure to other gastropods, and materials scientists are already learning things from how that shell is so good at resisting mechanical damage, and also how it makes its metal plates. Okay, those metal plates on its foot, because it does something quite remarkable that material scientists would really like to be able to do for us. Okay, so I want you to research some of the things that we can learn from species like this, and therefore why it's important that we protect them for the future.